Hi there. Welcome back to the Science House Express chat. I'm Gina Barrier, the director of the Northwestern Satellite Office of the Science House of NC State University. And today we're chatting with Dr. Amber Hubbard, a recent graduate of NC State. Dr. Hubbard joined the Department of Chemical and Biomolecular Engineering at NC State in 2014 as an NSF Graduate Research Fellow studying stimuli-responsive polymers. Prior to that, she graduated from Auburn University with her bachelor's degree in chemical engineering with a specialization in biomedical engineering. Since graduating from NC State, she's begun a postdoc position working at the Air Force Research Laboratory, continuing her research on polymer materials. She has a passion for mentoring undergraduate students, public speaking, and organizing student outreach. She's also an award-winning photographer. Dr. Hubbard, thank you for joining us. We're so excited to speak with you today.
Thank you so much for having me. It's a pleasure to be here.
But tell us a little bit about yourself and what drew your interest into this field.
Sure. So like you mentioned, I'm actually from Alabama, and I finished my bachelor's degree at Auburn. And so what's so interesting about that is when I started, I always knew that I wanted to go into a STEM field. But I actually thought I wanted to become a veterinarian. And so I had sort of gone through all of undergrad prepared to be a veterinarian, and then completely changed my mind because I had the chance to do an undergrad research opportunity dealing with materials research and with materials characterization. So I had the chance, and I started at NC State working on polymer materials and just fell in love with the idea of being able to tailor this new property, this new material that's going to impact a lot of people, having the chance to sort of look at a product or a paper or an idea and know that you are a part of helping to make that happen. And so that's kind of what drew me into not just materials research, but specifically polymers research, because polymers are just everywhere. You know, whether it's the toothbrush that you're using in the morning, if it's the tires that are on your car, the water bottle sitting on your desk, they're kind of everywhere, and you have the chance to help improve different properties so that you can create new innovative products or ideas and move them forward just a little bit at a time.
Great. I love polymers too, being a former chemist. Tell us a little bit about your research experience.
Yeah, so like I mentioned, you know, I started at Auburn University, and I was working on these very small nanomaterials. I was working on carbon nanotubes, if you're familiar with that or if you've heard of those. And then they were really small and I couldn't see them. And so what I ended up doing when I came to NC State was I said, you know, I want to work on polymers. I don't know anything about them, right? I finished my bachelor's degree in chemical engineering, and I really didn't have a lot of information about them. So when I came to the chemical engineering department at NC State, I approached Dr. Michael Dickey and Dr. Jan Genzer, who ended up becoming my advisors, and said, I don't know anything about polymers, but I really want to learn about them. And they were both wonderful, and they said, that's fine. Come on into the groups. We'll teach you what you need to know. And they really did. So the project that I worked on for all 5 years when I was at NC State was stimuli-responsive polymers. And it's kind of buzzwords and it sounds big, but the entire idea is to take these plastic materials that you know and then to make them move on their own. So you can think about robots, right? So they can move and they can perform functions. They can pick things up. They can move them to other places. And a human being doesn't have to be there to tell them how to do that function. So instead of having these sort of metallic objects that are big and that are heavy, you can do similar things with polymers. And the idea is to have a flat surface of material. So it can look like a thick sheet of cardstock, or it can look like, you know, a thick sheet of material similar to what you have in an airplane window. Actually, that exact same material of plexiglass was something I used during my PhD. And if you just expose it to light, or if you expose it to heat or solvent, depending on what your flat sheet of material is made of, it can transform into this three-dimensional object. So we can see where we have flat sheets of material, we shine a light on them, and then they transform within seconds into a sphere, or maybe it's a gripper that can pick up a small object and move it to somewhere else. And it can turn into a cube in a matter of seconds. And that's kind of the entire idea behind stimuli-responsive polymers.
Thank you.
So one of the things that's so exciting about the work that we do and working with stimuli-responsive polymers is having the chance to make them move on demand. And you can do this in a variety of ways. So here we have just a flat sheet of material and we shine this red light on it. And what you see is that in real time, in just a matter of seconds, it goes from a flat sheet and transforms into this interestingly curved object. But there's so many things you can play around with. So if you change sort of where you place that ink, so in this case, the ink is just in a different location, and now you have a completely new shape. This looks a little bit like a snail. And so if you place it in these different objects, in these different areas, different light, here we can generate a spiral, for example, and there's just so many options in terms of going from a flat object into a three-dimensional one. So it can start to do some pretty interesting things for applications.
So, Dr. Hubbard, what drives your passion for sharing polymer research or education with students and families?
Well, I think one of the most obvious and one of the easiest explanations is that not only have I mentioned, polymers are everywhere around us. And so if you're thinking about just polymers in general, whether you realize it or not, you're going to be touching and using or implementing some polymer material every single day. So if it's your toothbrush, if it is your water bottle, every few years you might get a brand new pair of tennis shoes. And some of that research is driving, making them a little bit better, helping you go a little bit faster. But the thing that's exciting about the particular work I've done, so the video that you just saw, is that you have the chance to sort of look at how cool it can be, right? It's exciting to watch a plain flat sheet of material just transform into a sphere because you told it to, and you don't have to manually manipulate it. It has a chance to do it on its own. And so you can turn it into so many different objects, and you can start to perform functions. If you're picking something up, if you're turning it into this really complex three-dimensional shape, and you are the one who got to sort of change where you're moving those things around. So it can tend to get people excited, not just about polymers, but also about science in general, right? So if I think about sort of this far stretching, what would be the coolest application that could impact your everyday life from this moving material? Imagine if you go to IKEA and you buy a bookshelf. When you come home and you have to put it together, there's a million pieces, it takes your entire Saturday afternoon. But imagine if you could just plug it into the wall and in about 10 minutes, your bookshelf just unfolded itself into the shape that you wanted.
That
Right?
would be so cool.
It saves so much time. I mean, some people I love putting bookshelves and desks together and doing that stuff, but imagine how convenient that would be. And so this is a cool opportunity to show people that, if you do go into science or any STEM field, you have the chance to impact people every single day and sort of dream those big ideas of what could you do that could impact someone every day.
Thank you. What is the coolest thing about your work as a researcher?
Yeah, so I think if you're talking about research or pretty much just being in the scientific community, my favorite part has been having the chance to just work with so many different people. So even just in the 5 years that I was at NC State, I got to present my work in the UK at a conference. I went to a program and got to present some of my work in Germany. And then I actually had the chance to do a 5-month internship where I was living in Japan for 5 months, working in a lab over at a university there. And so not only do you have the chance to travel, which I love to travel, so it's a huge passion of mine, which is exciting, but you have the chance to meet so many different people. You're meeting researchers and graduate students and undergraduate students and professors from all over the world. And so at this point, I have friends who live in various different countries all over the world working on some really cool research. And so you get the chance to learn from so many people, not just scientifically and academically, but on a personal level too, which can be pretty exciting. And it's nice when you show up to a conference that's, over in Europe and you start talking to these people. And if you say, what is the Young's modulus of your material, this material property, everybody knows what you're talking about. So you have a chance to kind of speak this almost universal language across material scientists, which is kind of cool, and it's sort of an added bonus of being a researcher because the scientific community is surprisingly and wonderfully a very international community.
It is, very much so. So what are the challenges of being a researcher?
Yeah, I think the biggest challenge that you face when you start a research project, if you're going into the lab and you have this idea, I know where I want to get. I think I know maybe what would happen if I tried a few experiments, but you just truly have no idea where it's going to end up. So some of the projects that ended up being the most successful during my PhD when I was finishing at NC State are projects that I started it and I had no idea where I was going. Or I had this idea and I presented it to my advisors and they didn't really see what the end output was going to be, but I had this idea. And so I like to think about it as if, you're a contractor and you're going to build a house, but you don't have the blueprint for the house. You just know how to work some of the tools, right? You know how to work a drill and you know how to use a hammer, but you don't really know what it's going to look like as you're trying to construct it. And so then you move on to a different project, but now you're not building a house, maybe you're building, a museum. So maybe it's a larger project with a bigger question. And so you have to get comfortable with the idea of going into the lab and things are going to fail, right? You're going to try experiments. You may be in the lab, for an entire week and your projects are just not going in the direction you want them to go. But eventually you're going to get there and you're going to have that sort of aha moment, that eureka moment, and you're going to be able to figure it out. So it's a challenge, not really knowing where you're going to go, but it's also nice because it never gets boring, right? What you're going to do in lab today is a little bit different than what you did yesterday, and it's going to be a little bit different tomorrow because you're improving upon it as you're working through a project.
Right. It sounds so exciting. And our students need to know that it's okay to fail because we learn as much from our failures, if not more, than we do our successes.
Absolutely true, yeah.
Our theme this week is polymers and their properties. What makes polymers exciting and relevant to your research and to the world?
So in terms of looking at polymers and how they're related to my research, I would say it's the foundation. It's the building block for the research that I've been doing. And so the entire idea, as you saw in the video and as I've kind of talked about, you have to start with a basic polymer material in order to make a polymer material move, right? So it's sort of the underlying idea of what we're working with. Imagine, trying to sit down and write a letter but not having any paper, right? We have to have it. But I think if you're looking at just the community or if you're looking at the world as a whole, I've already said polymers are kind of everywhere, right? But the exciting thing about them and the thing that is so just exciting to look forward to is the fact that they're not going to go away, right? So they're constantly being improved. Whether you know it or not, there is a researcher, an engineer, a scientist out there right now that is working on a product to make it better, to help make your life a little bit more convenient, right? So whether or not it's a new food storage container to improve oxygen permeability or decrease oxygen permeability so your food stays a little bit fresher in the fridge, whether or not it's buying that new pair of tennis shoes so it helps you run a little bit faster the next time you go outside, they're constantly being improved and there's so much room for improvement, right? And if we even focus in just on stimuli-responsive polymers, there's some really cool work being done where, for example, you can have little tiny grippers that can go inside the body. And now they can start to maybe grab small pieces of your liver if you need to have your liver tested. Or you can have a heart stent that can go into your heart and then it can inflate right when you need it to, where you need it to. Whether or not you're going from something as technical as that to sort of helping you medically, or if it's that idea of having a bookshelf that can unfold itself, right? It's everywhere and there's so many possibilities. And so that's kind of just what keeps it exciting as you're continuing to work with polymers.
So what advice would you give to young students wanting to go into your field of research or STEM in general?
Yeah, so if you're interested in going into a STEM field, there's really sort of two different things that I think are important to keep in mind, particularly if you're maybe finishing up your high school career, if you're considering going to college and pursuing a STEM field. I think it's important to remember, or at least go into it with the mindset that it's a challenge, right? So the way that you're able to make these huge impacts and the way that you're able to solve these really big problems, it is a challenging field to go into. But I think it's important to accept that as something that just is a challenge that you can overcome. You can absolutely make a difference going into a STEM field. And there's so many exciting things you can do. In the sense of you go into work and you're not going to be bored and you're going to be making a difference and you're going to be thinking of a new thought that maybe no one's ever thought of before. Or you're going to notice a new and interesting blip on a graph And that blip is going to tell you something about the material that no one's noticed before. But it is a challenge. And so I think it's important, if you're going into college or pursuing that STEM field, just to recognize that it's a challenge. You can absolutely rise to it. If I can do it, you can do it. But just to keep that in mind as you're moving in. And then, we've already mentioned that it's okay to fail. It's okay to not know what you want to do. When I started, I thought I was going to be a veterinarian. And here I am, I'm a chemical engineer, and I just finished not just 4 years, but 9 years of getting my PhD in chemical engineering. And I love what I do, and I love what I get to go in and solve and the problems I work on every day. But it's okay to not know, right? So I did an internship in veterinary medicine to figure out that's not what I wanted to do. So it's just as important to figure out what you don't want to do as it is important to figure out what you are passionate about. And so I think it's just important to keep that in mind. Ask questions, talk to people, take internships, and just figure out where your passion lies in it.
Thank you so much for joining me today. I hope you enjoyed our chat with Dr. Amber Hubbard. Next week, we'll be speaking to another great scientist, so be sure to join in. Until next time, be sure to like and subscribe to our channel. Additional information can be found in the description box below. And thank you for watching our Science House Express chat. See you next week.